¿Es el gas natural realmente la única solución para la energía en México? Nuestro país está poniendo sus esperanzas en el gas natural, que se ha constituido como un combustible de transición fundamental. Para ello, se han anunciado inversiones para que la red de gasoductos se incremente hasta en un 75% para el año 2018. A su vez, el sector eléctrico está transformando sus procesos para sustituir el uso de combustóleo por gas natural. Sin embargo, hay que considerar que la producción de gas natural alcanzó su pico en 2010 y ahora la importación va en aumento. En ese contexto, es importante analizar ¿de dónde viene el gas que se importa? Según la Prospectiva de Gas Natural 2013-2017, el 78.5% de la importación proviene de los Estados Unidos por medio de gasoductos y en porcentajes menores de otros países en forma de gas licuado. Por lo que se debe evaluar también el riesgo que implica la enorme dependencia que se mantiene del vecino país del norte. Además, hay que considerar que en los mejores escenarios, los precios del gas natural aumentarán en los siguientes años. Así entonces, es pertinente plantearse la pregunta: ¿el gas natural es realmente la solución a los problemas de energía? ¿Tiene la industria mexicana otras alternativas energéticas? Para Energías Saubere es un placer presentar a Christian Haller, quien nos platicará acerca de las alternativas en energía solar para generación de calor en la industria. Christian Haller recibió el Premio Internacional a la Innovación en Cambio Climático y Medio Ambiente 2015 por sus aportaciones a la transferencia tecnológica de los colectores solares Fresnel.
Hello everybody, welcome to our second webinar on solar process heat in industry, sustainable energy solutions for industry, under the title today, Natural Gas, is it the real solution? The first slide you see here shows an industrial area around the turn of the century, and as you can see, it's full of smoking chimneys. And nowadays even the pictograms that are used for industry are using the symbol of a smoking industry to represent successful industry. What has changed so far? Not too much. As you can see here on the next slide, which shows an industrial area a couple of years back in the US, still full of smoking chimneys. Basically, we're burning more and more fossil fuels, and we are emitting too much emissions to our atmosphere. This slide now shows you the total carbon emissions from fossil fuels over the last 200 years approximately. And you can see the beginning of the industrialization and the strong rise of our emissions to the atmosphere. So you all know that we have to act, we have to do something, and it's not only private people trying to save energy and trying to have a greener lifestyle, but also industry has to contribute its part. And when you talk to industry, you come very quickly to the question, how much does it cost? And we're always in the situation that we have to compete with fossil fuel, but it's a rather unfair game as there are tremendously high subsidies for fossil fuel. So this number you can see here, $5.3 trillion a year, is a gigantic number, and it's equivalent to about $10 million a minute. So being competitive with fossil fuel, representing or trying to sell renewable energy is quite difficult nowadays. But anyway, we are doing it, and we're reaching reasonable costs, and we are competitive with fossil fuels. Some words about our company. Industrial Solar, we are a solution provider for sustainable energy supply in industry, based on a rather broad portfolio of technologies, but we're also doing consulting for companies and for policymakers. We are based in Freiburg, Germany, in the Black Forest, and we have founded our company back in 2008, and our early days, we started our activities in our mother company back in the late 90s, where we did consulting for CSP companies, developing collectors, evaluating collector technologies for CSP, solar thermal power generation applications, and such. We get a lot of know-how, and after a while we thought about how to use this know-how, and as we didn't want to address the solar thermal electricity generation market, we decided to use this know-how to provide a solution to industry. And we did so, and we did build our first prototype in 2005, a linear concentrating Fresnel collector, which is capable of generating temperatures up to 380 degrees C with thermal oil, and which is nowadays commonly used for temperature range around 200 degrees C, generating steam. But before I talk too much about the Fresnel, let's move forward. We're not only offering our Fresnel collector, but also other technologies. Like photovoltaics or air collectors, flat plate collectors, vacuum tube collectors, absorption chillers to generate cold for air conditioning and process cold, heat pumps, and we even offer conventional fossil-fired systems as backup, like cogeneration systems or microgas turbines. So we can provide a customized solution for industrial customers, covering different types of energy demands like electricity or heat or cold. We address this market of industry, as industry is responsible for a big share of our primary energy consumption. About 27% of our primary energy is used by industry, and of energy which is required by industry is required in forms of thermal energy, meaning heat or cold, and only about 1/3 is used in the form of electric energy. And if you have a closer look at this process heat demand, you realize that more than half of it is in a temperature range below 400 degrees C, which can be supplied with solar technologies. Talking about sun, sitting here in shady Freiburg today with an overcast sky, it's raining a little bit. I hope the weather is better in Mexico. I'm almost jealous to look at your map of the solar potential. This map is showing you the direct normal irradiation. The more red, the better. So the regions in the northwest of Mexico are really blessed with very high radiation, reaching values of more than 3,000 kilowatt hours per square meter per year. We in Germany, we typically have around about 1/3 or even less. I think in Freiburg we have around 920, 930 kilowatt hours per square meter a year. So you don't reach these low values in any point in Mexico. So the worst point in Mexico is better than Germany. So Mexico is the perfect place to use solar technologies, also concentrating solar technologies, which can only make use of the direct radiation. Non-concentrating solar technologies, they can also make use of the diffuse part of the solar radiation. And they are, for example, better suited for the areas on your map which are more greenish and bluish. But if you are in a region which is more yellowish and reddish, then it's a perfect place for concentrating solar. Talking about the potential, let me show you some numbers. Here are some simulation of different places in Mexico, like Puebla, Culiacan, Guadalajara, Monterrey, Hermosillo. And this yellow-orange bar represents the direct normal irradiation, and the blue bar represents the gross heat production. These numbers are referring to a linear concentrating Fresnel collector. And the purple dots you see up there, the purple squares, are representing the mean yearly efficiency. And you can see that all over Mexico, we are reaching mean yearly efficiencies around above 40%, somewhere between 40 and 45%. This is extremely good. Here in Germany, we reach like 27, 28. If you go down to Spain, southern Spain, Andalusia, we can reach like 35, 38. The closer you come to the equator, and if you come to higher altitudes, like it's very often the case in Mexico, the better it gets. And so we can reach these high values there. It gets even a bit better, for example, in the northeast of Brazil, where we are closer to the equator and have a similar weather like you have. There we can reach values close to 50%. Future market of solar. This slide shows you the future market that is based on the roadmap by the European Association for Solar Heating and Cooling. The brighter blue shows solar water heating. The purple is solar space heating. And the biggest chunk here actually is the process heat for solar process heat for industry. In the low temperature range, process people are referring low temperature to temperatures up to 250 degrees C. There's a little confusion with these temperature ranges. Solar people are more like talking about medium temperature range. But anyway, this is the temperature range which is very often needed in industry, temperatures up to 250 degrees C. And the prediction for this market is a very strong growth. But also space cooling and solar swimming pool heating is a no-brainer. That's a very simple collector technology and with a very, very short payback time. So which sectors actually do need process heat? Here's a list which could be continued over several meters, I guess, but just to give you some examples, dairies, they typically have processes like pasteurization, sterilization, drying, and so on, and their typical process heat demand is in a temperature range from 60 to 180. Food, pharmaceutical, we just did a project for a pharmaceutical company in Jordan where we installed a directly steam generating system for this company. This system is working very well. We are now, we just received the order for a solar air collector system for another pharmaceutical company for a drying application. So there is a big potential. Textile, of course, processes like bleaching, dyeing, drying, and so on. Paper industry, which is not that simple because paper industry typically burns their waste, like waste wood or waste paper. So there we have the chance to add something if they're still using fossil fuel, not only their own waste. Chemical industry, meat, I think that's also a very big branch in Mexico. Beverage, breweries is a very nice example. And so on and so on. Plastics, automotive, we do cooperate with providers of paint shops for automotive industry. There, the paint on the car's body has to be dried, and we can provide the process heat for these paint shops and automotive industry. Tobacco, that's also a nice coincidence. We are now negotiating a contract with a tobacco company also for a larger process heat system directly generating steam. Yeah, this is a slide showing the situation in the US. We didn't find a similar slide for Mexico, but this is just an example to show you how inefficient our system is. These numbers are probably also true for Mexico and also similar for Europe and other parts of the world. So on the left-hand side, you do have the energy inputs like non-renewable fuels, fossil fuels, nuclear, geothermal, hydropower, all the renewables and biomass. And you have the economy, which is using this energy input. And then you see on the right-hand side the outputs. And that's pretty disappointing from my point of view, because the useful energy is only 9% of all the energy inputs. That's very, very little. 7% is in form of petrochemicals, also useful, but then we have the unavoidable energy waste due to limitations in efficiency, for example, and then we have a huge, huge block, 43% unnecessary energy waste. And of course, before we talk about renewable energies, we have to tackle these chunk of unnecessary energy waste and reduce the waste of energy. What? It's not coming. Okay. I just get a message that you cannot hear me. Sorry for the interruption. I have to check that. Can you please tell me if you can hear me loud and clearly? Go ahead. Okay, so obviously the problem was solved. So let's go on. What is our approach? Of course, we want to first harvest the low-hanging fruits, like we do an energy monitoring at a potential customer. Then we analyze these data that we gathered with the energy monitoring, and then we see if we can save energy and increase the efficiency. And when we have increased the efficiency and reduced the waste of energy, then in the next phase we integrate renewable energy technologies. What technologies can we apply? So here you see like a little overview of different solar thermal technologies. They are sorted according to the working temperature. So you see the unglazed collectors, which are typically used for swimming pool heating or applications where you need very low temperatures, slightly above the ambient temperatures. If you need higher temperatures, then flat plate collectors are an appropriate technology. And if you go to even higher temperatures, like in the range of 80 degrees and up, vacuum tube collectors or evacuated flat plate collectors are an option. And if you come to even higher temperatures, then you come to the concentrating solar technologies, typically the linear concentrating solar thermal technologies with point focusing systems like power towers. You can reach much higher temperatures, but this is more like for the future, that you can provide process heat in a temperature range of like almost 1000 degrees C for metal and glass industry with point focusing systems. So for the time being, I think the linear concentrating systems like Fresnel or parabolic trough are a very good technology to provide process heat in a temperature range, in a valuable temperature range to industry. Because as far as I learned from our discussions in Germany and all over the world, industry has very often waste heat in a temperature range that can be provided by, like, say, flat plate collectors or even vacuum tube collectors. And the thermal energy demand is more in a temperature range above 120 degrees C. And this is clearly the section where linear concentrating collectors can be applied. So when we talk to a customer and talk about feasibility of the project, then you have to take certain criteria into account. As you can see here in this nice colorful slide, we have to look at the budget, of course. We have to see the load profile. If you go for thermal technologies, it is not feasible to store thermal energy over a longer period, like days and weeks. We typically integrate short-time buffer storages. But if a company is shutting down their production like every weekend from Friday to Sunday, then you have a problem with thermal systems. So we need, for solar thermal technologies, we need more like companies that operate 24/7. Or this is the simplest case. Depending on the temperature range, we can choose the collector, or we have to choose the appropriate collector technology. Supply temperature, that's a discussion we always have. You can, for example, if you have a company with different processes on different temperature levels, you could integrate non-concentrating collectors and integrate this heat from these collectors on the process temperature level, meaning that you have to tackle the production process, which is very often not wanted by the customer. So our approach with the linear concentrating Fresnel collector is that we provide heat on the supply temperature. So if you operate a boiler fired with biomass or fossil fuel like oil or gas, you operate a boiler that is, for example, generating steam, and you would like to reduce your emissions and your energy bills in the future, we would typically connect directly to your steam grid without tackling your production process or even the boiler. And the trick we do is there that, for example, we generate steam with a higher pressure in our solar collector system, and when you reach a certain pressure in the morning after heating up the system, then we inject the steam into the steam grid, and your boiler has the impression that there is no steam demand as long as we provide enough steam with our collector. So there is no need for a complex control system. Basically, we just replace steam in your grid and your boiler doesn't operate, your burner doesn't start. Another point to take into account, for example, feed water temperature. If you operate an open circuit with steam, meaning you lose the steam, you don't condensate it, you don't condense it, then you have to prepare feed water, and there is an opportunity to integrate, again, non-concentrating solar thermal technologies like flat plate collectors or vacuum tube collectors to preheat the feed water. Yes, and of course a very important criteria is the available space. So for all solar technologies you need space on rooftops or on the ground. With the linear Fresnel we need about 3,000 square meters for 1 megawatt peak power, and we have to see how much space is available, what is the capacity installed at the customer, and then try to design a system which is fitting the existing system, or which is matching the existing system. Talking about feasibility, financial feasibility, that's a very important part. We do a very detailed financial feasibility check together with the customer. This financial feasibility check is based on the investment that you would have to do to buy this solar field or the solar technology to be integrated in your existing system. And then we calculate like parameters like the net present value or the internal rate of return over 10 years, over 20 years, and also payback time. But actually the payback time is not really a good parameter to judge the feasibility of such a system. It's better to look at the internal rate of return, for example. These figures that you see on these slides are not too good. I mean, we have very often situations where we reach values here, internal rate of return over 10 years, which are higher than zero. Over 20 years, it's more like 15 to 20%. And payback time, we want to be, or we're trying to come in a range between 5 and 8 years. But of course, this depends a lot on the cost of fossil fuel. And as you all know, oil and gas are rather cheap nowadays. You've seen the video at the beginning. So basically everybody thinks that gas is the best solution. It's definitely the cheapest solution, but you don't know what's going to happen in the future. And if you're going to invest your money in a solar technology placed on your company ground or on your rooftop, you know exactly what the energy from the system is going to cost you over the lifetime of the system. So there will not be unpleasant surprises in the future that these energy costs are going to rise. Of course, we are trying to harvest the low-hanging fruits first together with our customers, meaning, for example, if you generate heat with some boiler, some companies still do it with electricity, like if you generate steam in smaller scale, electric steam boilers are still quite common. There you could, for example, change to another fuel. Most inexpensive nowadays is natural gas, with all its back pros and risks. Of course, as I mentioned before, companies that operate all year, 365 days, 24 hours, are the best customers for solar thermal technologies. PV can be basically applied almost at every customer. Continuous demand is much easier to handle than, for example, batch processes, but also this is doable. I mentioned before a project that we are now negotiating, which is a hybrid system. We generate steam, and the steam is partly used in batch processes. And when there is no batch process running, we use the steam more to operate the absorption chiller, generate cold. So there are solutions even for discontinuous demands. Low temperatures, of course, it's cheaper, it's less expensive to generate low temperatures with solar thermal technologies. The higher the temperature, the more costly it gets, and the higher the temperature, the more complex are the collector technologies. Swimming pool collectors are extremely primitive. They can deliver you water with 25, 30 degrees C. But if you need steam at 250 degrees C, then you need a concentrating collector and you need a high pressure system, which is of course more costly. Large systems have a better economy of scale. Small systems are more expensive. This is also understandable. I think I don't have to explain you why. With concentrating solar thermal systems, you have a rather strong economy of scale if you need high temperatures, because there you need peripheral components like pumps, pressurization system, etc. And these peripheral components are even in small scale quite expensive. So high temperature, high pressure systems typically don't make economic sense in small scale. Small scale meaning 50, 100, 200, 300 kilowatt. I think it gets feasible from like 500 kilowatt above. We do have like a sweet spot in terms of size from like 3, 4, 5 megawatt up to 10, 12. If you are coming to 15 megawatt or more, then we are in competition with power plant technologies. If you want to go on rooftops, then concrete rooftops are typically much simpler. You can put a higher load on concrete rooftops. whereas on corrugated sheet metal rooftops, it's more difficult to install something on top. But depending on your energy demand in your company, we can, for example, install PV modules on corrugated sheet metal roofs and generate electricity. But if you want like steam for your process, then it's going to be more difficult. And of course, places with high radiation are more attractive. With the same investment, you will get a higher energy yield, meaning it's financially more attractive. You will have a higher internal rate of return. What are the challenges? What are our problems? Low energy costs, like fracking gas from the US is a real bummer for us, or now the low oil price. The high investment, with all renewable technologies, you are facing the situation that you have a rather high investment at the beginning. We are trying to help our customers with financing, meaning there are institutions out there like development banks and others that can give you a low interest loan to finance such a system. There are programs for that, and we are also working on energy contracting. There are financial partners which can do energy contracting. Basically, the financial partner is doing the investment and you're buying the energy. This is called energy contracting. There are also other models like BOT, build, operate, transfer. It's more like a leasing model. And there is a lot of movement currently in the market because most of the people have understood industry needs a lot of energy. Industry is open for clean energy because the customers are more and more sensitive towards this. If a company is acting clean and green, or if they are dirty, burning coal and heavy fuel oil. And the only hurdle we have to overcome is the financing. So there are many people out there and many projects currently, of which I know, which are working on this financing problem. And we are planning, not only us, but also others are planning to set up investment funds to finance such systems for industry. Of course, insufficient awareness. This is one major reason why we do this webinar today. Very often people in industry don't even know that there are technologies out there, market available, proven technologies that can provide clean energy for these industries. But also there are not too many solution providers which can provide this solar heat for industrial processes solutions. We are one of the few, and we have understood that that industry doesn't need a product, but they need a solution. So we are customizing solutions for you to meet your demands and to be most cost effective. In Mexico, there are not too many pilot projects yet. There are more and more all over the world. And yes, I'm always lucky to hear that more and more companies are starting this business. So this also proves that we are on the right track, and basically we are happy to have more and more competitors. Another point is missing support policies. So in many countries, there are no subsidy schemes or support policies for renewable energies used in industry environments. So some examples. These examples are not all from us, but I wanted to have an example for different technologies, different temperature levels. The first example is a meat factory in Austria. They need a lot of warm water. So some colleagues there installed a flat plate collector field with a total aperture area of more than 1,000 square meters. These are so-called high temperature flat plate collectors. And they gave a guaranteed solar yield of about 400 kilowatt hours per square meter in a year. Another example, also made by colleagues, the company Ritter XL in Germany. They made a system, a process heat system for metal industry in Switzerland. They installed evacuated tube collectors with CPC reflectors, total aperture area like 400 square meters, and outlet temperature is around 95 degrees C, and the heat is used for galvanization process. This is an example from us. It's an air collector system for pharmaceutical industry. It's also based on evacuated tubes. There's an aperture area of 130 square meters, and it's for a drying application at a pharmaceutical company. And actually this customer just ordered the second system because he is very content about the performance of the first system. This project I already mentioned before. This is our directly steam generating system which we recently installed, or which we installed last year at a pharmaceutical company in Jordan. It's this linear concentrating Fresnel collector, aperture area around 400 square meters, and it generates steam at 200 degrees C. Some aspects, of course, there's awareness of local industry. Supply, we need more availability of solutions. The viability of technology has to be proven. Economics have to be in acceptable range. And of course, we need financing model, and always a big issue, we need local value. And this is actually very well possible with our linear concentrating Fresnel collector. So we can source components locally, like the metal structure, which is basically metal profiles, and other parts that we can source locally. So we're coming to the end. Thank you very much. I hope it was interesting for you. This was our second webinar, and I think we're going to do more webinars in the near future. Please excuse that I didn't speak Spanish. It's not good enough yet, but I'm going to do my best to improve my Spanish, and hope that I can do a presentation in Spanish very soon. And please stay connected. Read our invitation emails. We will make more webinars also on other topics, more specific topics in the near future. So thank you very much, and stay in touch. Bye-bye. Have a nice day.